Hey guys, I'm recording this video. I'm using OBS Streamlabs. Hopefully this works out. I am recording this for Honors Chemistry, just going over everything for the test tomorrow. So I'm going to pull up a worksheet and let me know if this looks good. Let me actually make my webcam smaller because that is huge. And I think that looks pretty good. Hold on, let me make sure I'm properly capturing my display. I'll just assume I am. Okay, so the first things I wanted to go over real quick were just the metals, nonmetals, and metalloids, and name groups. Here's a periodic table similar to the one you will have. The line you'll have will be black, and you'll actually only have a line over here. I want to talk about this line. This is the metal-non-metal line. Anything to the left of this line, let me choose a color other than black and white actually. Oh. Shoot, that image went away. Let me bring it back. And let me choose red. Anything to the left of the line is a metal. That actually includes all of these as well. These are what we call our transition metals. These are our post-transition metals. The new elements down here are probably metals, although to be quite frank, they exist for such a short amount of time, we haven't really been able to study them. I'm not going to ask you about them anyways. These are all metals, right, with lithium and beryllium. All of those. I don't know why when I hit undo, that disappears. But it is annoying. I will note that I cannot hit undo. Alright, so anything to the left of this line is a metal, with one single exception, hydrogen. I have a line up here next to hydrogen to show that. However, normally a periodic table will not have this line. So you will not have this. But hydrogen is the one exception to this rule. It is a non-metal. Later on in the year, when we get into the basics of quantum mechanics, we'll get into why this is the case. But you can think about it this way, right? Each of the different electron shells, right, that we fill out, right, they all have 8, and they make that octet. You did this last year with Bohr's models, but the innermost one only has 2. Well, hydrogen is like halfway full, similar to carbon being halfway full. It has 1, 2, 3, 4 out of 8. So that's basically why. So anything to the left of this line is a metal. Anything to the right of this line is a non-metal. Helium, neon, argon, right, fluorine, chlorine, sulfur, oxygen, nitrogen, carbon, phosphorus, selenium, bromine, iodine, xenon, radon, right? All of these, krypton, are non-metals, in addition to hydrogen, which is over here, right? That one exception there. Now, finally, we have our third group. These are metalloids. Anything touching the line is a metalloid. A metalloid is halfway in between a metal and non-metal. So it conducts some electricity like a metal, but not a lot. It conducts some heat like a metal, but not a lot, right? Non-metals don't conduct heat, they don't conduct electricity. Basically, if you go through the properties, it's basically halfway in between. That is why we call them semimetals or metalloids. Anything touching this line is a metalloid with one exception: aluminum. Aluminum is a metal. So we have two exceptions we look at. We look at hydrogen, we look at aluminum. Depending on which table you look at, some people describe polonium here as a semi-metal, and some people describe it as a metal. So some people say it's a semi-metal or a metalloid. Some people say it's a metal. I'm not going to ask you about polonium anyway. We tend to stay away from the bottom of the periodic table. We tend to focus in mainly the first 20 elements, but really up to like xenon, I'd say up to like barium as a max, generally. Might get a little bit of mercury or gold mixed in the picture, but so you won't be asked about polonium. But aluminum is a metal, so you need to know two exceptions: hydrogen, aluminum. Aluminum is a metal, hydrogen is not. Okay. That is the periodic table as far as metals versus nonmetals versus metalloids go. Next, we actually have 4 groups in the periodic table. Right, 4 groups we have named. We have 8 groups in total. Group 1, 2, 3, 4, 5, 6, 7, and 8. These groups aren't really full official groups, so we won't worry about these. Well, okay, sorry. They are groups, but these are what we call transition metals. They're not the main groups. That's what I'll say. So here, our important main groups are the first 2 and the last 2. These are alkali. Let me actually put some text here. These are alkali. Whereas these ones are... I am on video. Oh boy. Alkaline. Alkaline earth metals are both reactive. First group is alkali. This includes lithium and everything down. Hydrogen, while it's part of the column, is actually part of the group. Alkaline is beryllium and down to radium. Both of these are reactive. Alkali are more reactive. It's because they only have 1 electron to lose instead of the 2 that alkaline metals have to form ions. Over here, we have oh, shoot. I accidentally hit the back button on my mouse. This is not going well. I'm sorry, guys. Alkali. Alkaline. Halogens. Halogens are the second to last group. These are highly reactive, generally dangerous chemicals in their elemental form, so when they are pure elements. As parts of compounds, it depends. Sometimes they can be dangerous, sometimes they can be harmless. And finally, noble gases. This last group here are noble gases. They do not react with anything, giving them the name noble gases. They're completely non-reactive. These are the 4 main groups you will need to know for the test. So you'll need to know these. You will need to know basic definitions, like what's an atom, what's a molecule, what's an element, right? What's a proton, what's a neutron? In addition, all right, what's an electron? In addition, right, you'll need to know the 4 named groups, and you'll need to be able to sort elements by, all right, metal, non-metal, or metalloid. So, starting up a new board here, you should also know isotopes. There are a few ways of writing and drawing isotopes. So let's say you have something like carbon 13. That means you have a carbon atom in mass number 13. That is protons plus neutrons. This can also be written as, right, I'll type this one out. You can see carbon 13. You can see carbon 13. In some cases, you can even see 13 as a superscript for carbon. So actually I'll draw that like this. Carbon 13 up on the left. But one final common way to show it, and I'll actually show you just like this with 2 numbers. Right, carbon 13 and 6. This being protons and this being mass number. This is kind of redundant because all carbons have 6 protons. So it's not actually giving you any new information, which is why you'll more commonly see these. But, right, it's just a bit of redundant information for you, so you don't have to look it up. So this would be, right, 7 neutrons. All right, 6, 7, and 13. The last thing I'm going to cover is the atomic mass calculations. So let's talk, let's invent an element. Let's just say AB 53, AB 52, and AB 55. Let's say this is about 25%. This is about 35%. And this is the remaining 40%. Well, when we are calculating the mass, we want to take the mass multiplied by the percentage plus the next mass multiplied by its percentage plus a third mass multiplied by its percentage. Percentages, right, per cent means per 100, right? Cent, century, 100 years, 100 cents in a dollar. So we just take the number, we divide it by 100. So this is the mass number. Let's use this mass. 53 times 25 over 100 plus 52 times 35 over 100. Right? 35 over 100 is also 0.35. This is also 0.25. And you can put it in your calculator as you see it like this. You don't have to, like, if you multiply something by a fraction, remember, multiplication and division happen at the same time. Your calculator knows that. you can type it in literally as I'm writing, right? 25 over 100 plus, right? And you just put in the plus. Don't hit enter anywhere in the calculator yet. Go all the way to the end, right? Without pressing enter. And remember to bring your calculators. $35 over 100 plus 55 times 40 over 100. Well, I multiply all of these. I'll put it in exactly as you see. Hopefully I can see if I can show it. 53 times 25 over 100 plus 52 times 35 over 100 plus 55 times 40 over 100. Right, hopefully this is showing up. I'm just gonna get trippy for a second just to see. Yeah, exactly that, right? I hit enter. I get my answer, 53.45. Your answer will not be that clean. Right, this would be the atomic mass, 53.45. Your answer will not be that clean because the percentages won't be exactly that, and the mass might not be exactly that. If you're given a more specific mass, just use that specific mass, but it doesn't change, right? If AB53 technically has a mass of 52.9836, then you just put in 52.9836. Right, and if it's technically 25.076%, right, just put 25.076 over 100. That part doesn't change. So if you're given a more specific mass, use that. If you're not, just use the number. And that's how you do atomic mass calculations. That covers everything you will be assessed on. Best of luck.